Hello everyone. Let's visit today's problem, and it says maximum Manhattan distance after k changes. So it basically says that you're given a string S consisting of north, south, east, west, where S of I indicates movements in an infinite grid. N means 1 unit north, S means south, E means east, W means west. Cool. Initially you are at origin O, and you can change at most k characters to any of the four directions. So if it's S, I can change it to N. Okay, whatever. Yeah, cool. So find the maximum Manhattan distance from the origin that can be achieved at any time. Hmm. Okay, so this is pretty interesting. At any time, while performing the movements in order, Manhattan distance between two cells is yeah. Okay, so they've given the formula basically. Okay, so I think as soon as reading the problem once and you're given the constraints that you can change at most k, the first thought that comes to my mind is of a recursive solution where we are basically going to try out every possible way. So it's basically like you either change or you don't change. And when you don't change, you okay. And when you change, you are going to change it to what? So that is the first thing that comes to my mind. Let me check the constraints. Okay, so it's 10 to the power 5 and k is also 10 to the power 5. So I don't think this would be very efficient. I don't think recursion would work as well. So I'm supposed to think of a better solution for probably in an O of n or O of n log n. Okay. So I do have a few observations over here. Let's say if I move 2 steps to the north, and the next letter which I encounter is S, so that means I'm supposed to move north itself and not basically means I'm supposed to change the south to north. And when I do that, the number of steps are going to be increased by 2. So so basically it means, let's say we have a string ns, and I encounter n, and that goes one unit to the north, and then I encounter S, and I change that S to north. So at this point my position would be 2 and not 0. So it's basically like I have around a difference of 2 over there if I'm changing one letter. So that is one thing. Another thing is the maximum which I can get at any position is the number of steps, and I don't think we can go beyond the number of steps. So it's like if I'm encountering the third letter of the string, the maximum string which the maximum Manhattan distance which I can get is 3, and there's no way that I can get more than that. So those two are the observations over there. And so this is what I'm thinking of, right? Uh, so basically, I'll for every north, south, east, west, I'll increment to whatever the respective letter is, and basically calculate the Manhattan distance. So what the Manhattan distance is basically north minus south plus east minus west, right? Cool. So that is the Manhattan distance. So once you get the Manhattan distance, you can basically check what can be the Manhattan distance, what is the maximum Manhattan distance that can be. So basically that means it's equal to the number of steps you have encountered minus your current Manhattan distance. So that would be the number of steps which you can, the maximum Manhattan distance which you can obtain. And now you are supposed to check if you can get to that maximum Manhattan distance. So how do you check that? Uh, so it's basically, I think we are supposed to bound the values to some constraints, and it would, I think, be 2 into k, because again the same reason which I told, when we change every letter we are increasing our current Manhattan distance by 2 units. So yeah, I think that is what we are supposed to do. Yeah, so basically, okay, so gathering all the thoughts together, I'll be incrementing the entire, I'll be traversing through the entire string once, and then I check for the current Manhattan distance, and I check for how much I can get, how much more I can get. and then increment my current Manhattan distance to how much more I can get. And that how much more I can get would basically be the minimum of 2 into k and the how much I can get. So that would basically be the answer, and then how much I can get would be added to the current Manhattan distance, and then my answer would be maxed over there. So yeah, that's I think it should work, and I feel like and I think it has a time complexity of O of n. Uh, yeah, so it has a time complexity of O of n, and I think it should be working. So let's just try and code it up once. Okay. So I'll have to convert this S into list first, and then find the len of S. My north, south, east, and west, everything initially would be 0. The number of steps I've encountered would also be 0. My current Manhattan distance would also be 0, and my answer would also be 0 initially. And I traverse through the entire string once. Okay, and increment by my steps by 1. And if S of I is n, then my north increases by 1. If S of I is south, then my south increases by 1. If S of I is east, then my east increases by 1. Otherwise, my west increases by 1, because these are the 4 letters that can be present in the string. There cannot be another letter present. Okay. And now I'm supposed to find the Manhattan distance. So my current Manhattan distance would be absolute of north minus south plus absolute of north minus south plus absolute of east minus west. And how much I can move, how much more I can move, can be moved would be steps minus current Manhattan distance. So the maximum which I can move is steps minus current. How much more maximum? The maximum how much more I can move is steps minus current Manhattan distance. And so if I change from there, how much can I recover? So I think I'll have to keep that variable also over here. Okay, let me keep it as 0, and if can be moved is greater than 0, then how much can I recover? How much can I recover? It would be minimum of 2 into k, and how much can be moved? Okay, and obviously my current Manhattan distance would be incremented by how much I can recover more, and my answer would be maximum of the answer and the current Manhattan distance. I would obviously return the answer over here. I think this should be working. I don't feel like there's any issue with the code over here. Okay, let me run it once. Okay, accepted. So okay, I'm okay. So I'm thinking of decrementing k also over here. So no, are we supposed to decrement k? Okay. I don't think we are supposed to decrement k over here. The reason being we are calculating the current Manhattan distance from the very beginning. And over here, we are not necessarily using the k. We are just checking if we apply k over here, what's going to happen. So we are supposed to do that for, okay. So I don't think we are supposed to decrement k anywhere over here. And I think this solution looks good. has a complexity of O of n. Okay, let's submit it and see. Yeah, cool, works. So yeah, and the time complexity obviously would be O of n because you are traversing through the entire string once. And yeah, that was today's problem. Let me know if there are improvements which I can make either to the code or the way how I'm communicating my thought process. Thank you.